Hello, everyone, and welcome to today's webinar with Witekio and Qt about how to seamlessly migrate Qt from an MPU to an MCU. Thank you so much for joining us. Thank you, everyone who's registered. If you're watching this on demand, which I know a few of you will be, if at the end, anyone who's in the live right now will be able to ask questions to our experts. And if you're watching this on demand, then you can always email us or put in the chat. Hi, Marcel in Munich. You can always email us or send us your questions, and the experts can answer it later. So I am Georgie Ryan Casling. I am the head of marketing and head of partnerships for Witekio. I'm here purely as your host and as someone who will ask the experts your questions at the end. So feel free to chat in the box, and I will reply so that our speakers can do what they do best, which is to talk, obviously. Just a quick reminder that we're very close to the Qt World Summit, which is in Berlin on November 28th and 29th. Witekio will be at that summit, so you can actually meet Rémi there if you're going, and he'll have a demo of what Witekio has done on the Qt framework before. And I'm sure obviously Yoann and the Qt team will be doing talks and lots of different subjects like the one today. So for sure, if you're already in Berlin or if you're attending to go, let us know so that we can come and say hi. So today, the agenda obviously is roughly what we're going to cover. It's talking about UI apps, application tools for widely varying hardware platforms from Qt, MPU to MCU with Qt success stories, how to leverage Qt for both MPU and MCU environments, expectations and challenges when transitioning, a live demonstration of QML application porting through Rémi, and then our expert tips and tricks for successful migration. So that's exactly what we're going to be covering, and probably a few more little spicy bits as well. I'm going to hand over to Rémi to introduce himself, and then he'll hand over to you.
Thank you very much. So I'm Rémi Roux. I'm the application team lead in Witekio. And I'm here today because my team and I are software specialists, and we are creating a high-end application and UI for our partners. And we are used to work with the Qt framework. But we are mainly working with MPU right now, and we want to talk about how to switch to the MCU world. And to you, Yoann.
Thanks, Rémi. Hello, everyone. So my name is Yoann Lopes. I'm a senior product manager at a Qt group. Responsible specifically for offering on microcontrollers. So today I will be explaining a bit what do we provide to help development teams to work with microcontrollers in addition to microprocessor, as well as give a few examples of real life, some of our customers, what they have done in this context. Right, so I'll start then with a very brief introduction about the Qt group. Maybe not all of you know the company. So we've been around for quite some time already, more than 25 years, if I'm not mistaken. We have millions of users around the world using the Qt library and tools, several thousand customers in many different industries. You might also know Qt as an open source, of course, project, but there is a company behind it as well. We're today more than 700 people working worldwide and growing very fast, as you can see here. Last year, I think 28%. So to continue making Qt an ever better product. And we are really focusing on enabling agile enterprises by providing more and more libraries and tools that cover all the main steps, I would say, of software creation, from design to development to quality assurance and also to management. So with the core Qt libraries, of course, but also tools like Squish for testing, or new tools like Qt Insight, for example, to help track the usage of the device that you deploy on the field. So now let's dig into the subject of today. So microcontroller and microprocessors. I hope you're all somewhat familiar with what the difference is between MCUs and MPUs, so MCU microcontroller and MPU microprocessor. There are some really important differences, and I don't want to give or spend too much time on the differences, but let's say that historically and traditionally they have been fairly separate, solving each fairly different problems, but not really much overlapping. But I think this is, at least recently, somewhat changing. And if we consider graphics application, that of course, Qt being mostly known as a graphics UI development framework, if we look at this specifically, we have today more and more new high performance microcontrollers that are actually very capable for graphics and even in some cases better than some microprocessors. In parallel to that, we know that microcontrollers can be actually easier to use than a microprocessor due to their simplicity mostly, but also they have a set of unique advantages that I will detail a bit in the next slide. But overall, basically, it has become now a fact that for some types of applications and some types of devices, where previously and several years ago, MPs would always have been used and always have been the choice. There are now cases where microcontrollers can be a better choice. So, what are some of the advantages or unique advantages of a microcontroller over an MPU? The first one I've listed here is real-time processing. Again, due to the simplicity mainly of microcontrollers, it can be a better option than microprocessor. For example, simply because latency can be lower, for example, so it can be a better option to make sure that tasks done by the device are done, let's say, on time. The second one would be power consumption. Typically, a microcontroller um, uh, use less power than a microprocessor. So for devices, for example, powered by a battery, it can be a better choice. And related to that, now we have also thermal management. Due to the lower power consumption, typically an MCU will produce less heat, and therefore the overall design is simpler as there doesn't need to be complex thermal dissipation like methods. Then we have the boot time, especially when there's a human-machine interface on a device. It is most of the time essential that when the device starts up, that the user must be able, he must be able to interact with it as quickly as possible. And this can often be a very difficult challenge on MPU to make sure that the device boots as fast as possible. With microcontroller, again, this is typically much simpler. Again, always due to one fact that MCUs, the software and the hardware are much simpler. And last but not least, the cost obviously is most of the time, again, lower with an MCU. It's not just the MCU itself, it's also the overall hardware around it. For example, memory. You will often not have external memories, or at least RAM, with an MCU, and other components that you might not need either. So, yeah, these are essentially a high level summary of why today you might want an MCU over an MCU. But then where we come into play here at Qt is making this simpler and easier because in a context of a company creating multiple devices at different price points, you might have teams that need to develop in essentially a unified user experience, but across very different types of hardware, as I said, MCU and MPU, for example, but also operating systems and even in some cases also mobile with mobile companions, for example, and making sure that there is a homogeneous user experience across all these devices and maintaining it in the same way can be very costly again. So at Qt, we're creating again tools and libraries to enable having a common workflow and reusing code as much as possible across these very different types of devices. So let's have a look now at, well, some of the prerequisites when considering graphical user interfaces on MCUs. It's not just, even though I said they are getting closer and closer in terms of power and capabilities, or at least there's an overlap, uh, there are certain things to be aware of. You cannot just go from MPU to an MCU without considering these. So the first one would be the resolution, the display resolution. Even with the increased power, they're still, let's say, typically not adequate for very high resolutions. So what we see today most of the time is that a display resolution would be between 320 by 240 up to 1280 by 720. But there are even today now starting to appear some very high performance MCUs that can even drive up to full HD display. But again, that remains an exception more than the rule. But again, if you really need high resolution, chances that there might not be an MCU that can solve this problem. Then 3D. Again, we see 3D more and more in all kinds of user interfaces on devices, and Qt in general, by the way, of course, can help with that. But on MCUs, this is typically not really doable, at least not real time. There's just no hardware acceleration available on MCUs to do real-time 3D. However, and I wanted to mention that it does not completely exclude some use cases. It is still possible, again, nowadays, to do pre-rendered 3D, like image sequences, or even real-time 2.5D. Some MCUs today have GPUs or graphics processing units that can do 2.5D, which means for those of you not familiar with the concept, is to render, let's say, 2D objects like an image in the 3D space. So it's kind of like 3D, but not really 3D. And finally, generally, any kind of complex multi-process software architectures are not fit for microcontrollers, again, due to the nature of the hardware and what it can do. So typically, a software would need to remain simple when it comes to its architecture. So a bit more concretely now, what does Qt actually offer here for MCUs? Because again, I'm assuming many of you already know Qt, but you might not know what is called Qt for MCUs. It's a new part of our, let's say, libraries that we released now already back in December 2019. So it's not entirely new. But essentially, it's about bringing some of the core technologies and tools from Qt also on MCUs. We have already been supporting desktop, mobile, web, MPUs for a long time, but we were still missing this last piece of the puzzle, which is MCU. So the key, really key technology of Qt at the core of pretty much everything is Qt Quick and the language that goes with it, the QML language. So we took these two core parts and adapted them also for MCUs or more generally resource constrained systems so that it's much smaller and more adapted to these systems. And at the same time, we kept the tools that are known by all Qt developers, Design Studio and Qt Creator, that offer, again, similar development environment for creating Qt applications. And here I've summarized some of the key features of the engine behind all of this, basically the engine for QML on microcontrollers. We call it Qt Quick Ultralight. This is I'm going to call it Big Qt. There's something called just Qt Quick in Qt for MCUs. There's Qt Quick Ultralight that basically indicates that it's a smaller version, but also a subset of the features we offer on our platforms. But here it really just summarized some key aspects. So I would say the most important of all is the size. And you see here on the second item on the list, Qt Quick Ultralight or a Qt application on MCU would can require as little as 200 kilobytes of RAM. It can, of course, be larger depending on your requirements and your design, but it can be as low as that. If we compare this to a big Qt application, the minimum requirement would be typically closer to 10 megabytes. So it's really a significant difference. And so this Qt Ultralight runtime is much more adapted to a typical MCU environment. There are other things that basically covers all the important aspects of a graphics engine, from font rendering to 2D shape to animation system and so on. This is all documented on our website. So if you're more curious about it, of course you can find more info on our website. Um, I wanted also here to give you a brief overview of the architecture, because it's also, if you're not familiar with the differences, it can be quite different. On an MCU, it's on the left side, it's pretty simple. It's typically a monolithic architecture where you have everything built into a single binary where it contains the application code itself, of course, and the GUI code. Optionally, a real-time operating system. It's not always the case, and then the drivers, and then just the MCU. So it stays really simple. And Qt, in this context, it's a very important aspect, can run straight on top of the drivers. Therefore, it can run bare metal. However, on an MPU, it looks a bit different. There's more layers, let's say, and a GUI application would typically run on top of other middleware. It will never run directly on top of the OS kernel or the drivers or anything like that. And therefore, the big Qt always have dependencies on specific operating systems like Windows, like Linux, QNX, and others. So this is again a key difference. Qt Quick Ultralight does not have any OS dependency, while Big Qt for MPU has always an OS dependency. But how can you actually in the end reuse, especially code between these two architecture being so different? It all comes down to the QML again. It's this common language, an approach to the GUI itself, and being a subset and being fully compatible, it is possible to create a common library of QML components that you can reuse on both types of devices and systems. So now I will give you a couple of examples from our customers that we can share some information about. The first one is Yanfeng Vision, one of our customers in China, an automotive tier one supplier for different brands locally. What's interesting here is that, again, due to the rise of some more powerful MCUs, they decided for some of their products, which is like entry level instrument clusters, as you see some examples on the right, they have been so far always created these entry level instrument clusters based on MPUs, because that was all that could really solve all of the requirements. But now, as I said at the beginning, due to the rise of these more powerful MCUs, they decided to take a leap, let's say, and really give a chance to a new platform that would be based on an MCU to actually solve the exact same requirement, same display resolution, same kind of effects, screens, and so on, and do it on MCU instead, with mainly, let's say, cost in mind, right? So really to reduce the overall cost of our platform. And independently from that, they had, of course, Qt developers, because they were already working on MPU, and the result was successful. There's not much I can share, but there are cars today based on this new platform, and they've been able to leverage all of their knowledge, resources, and in some cases even code that they already had done on this new MCU platform. And then the second case that I wanted to give you as an example is a bit different. This is with Hasselblad, a Swedish camera manufacturer. You might know it if you're a photography enthusiast. So they not too long ago released a new model that basically innovates in a way that the top level screen, you can see it on the right here of the picture. This is always on every camera, this kind of small display that shows all kinds of information. But what they did is they wanted to go a bit further, like in improving the experience. So having a color LCD with ability to display more information. But they basically have been using Qt already on the bigger display in the back. which is running on Linux and more complex system. But this was much simpler, and it is basically running on an MCU. And they did not want to, use a different toolkit, use a different approach to this. So in this case, they selected Qt for MCUs to also develop that part, and again, they were able to their reuse the same workflow, reuse the same tools, reuse the same people to develop this as well. And they've done that successfully with the device today, available already for quite some time on the market. And that concludes my part. So thank you for listening. And I leave it to Rémi, who will explain a bit more in details, concretely what it means here to do the switch.
Sorry, Rémi, we can't hear you.
Yeah, let's try like that.
There you go.
Yeah, sorry. Thank you, Yoann. So as you said, there is a new product, Qt for MCU. Not that new, but and the MCU market is now changing. The MCU are more and more powerful. So the goal here is to handle this technology switch. In Witekio, we saw two approaches. Either you take someone with a lot of MCU knowledge and you teach him how to create applications, or you take someone with all the application knowledge, knowing how to build intuitive UIs, and you teach him the MCU world, more or less. And the results were quite funny. Actually, the team on the MCU part, everyone almost ended up with some PTSD by creating UI. I mean, not using the Qt for MCU framework, because placing items on the screen pixel perfect or changing only the color or really taking care of the user experience is not that easy. And the result with using my team was, let's say, way better, and we really enjoyed the trip.
Well, I'm glad you not all have PTSD now. That's good.
Yeah, no. I can reassure you, right now they are working on drivers and they are making LED blinks, so they are really, really happy. So just a disclaimer, the team and I, we had really no knowledge about the MCU world before this dive, let's say. So my first fear was about the developer environment. I was seeing the MCU world as something old, only using C, and if you need to display an images, you will have to light every pixel by hand. So I wanted to really see what can translate from one of our classical projects. So here, I just listed every tool that we can use in one of our projects. And I want to mention also the environment, because it's really something that we want to have quality work, it being able to run our code both on the target and on the desktop. And the differences actually were really limited. When we switched into the MCU world, everything was there. The IDEs, we are using all the CMake to handle the build and the packaging process too. The main differences was where to get the compiler for your target, because we are used to the Yocto project generating us everything. Here it's not the case, obviously. We are also using containers, so everything from a modern development standpoint is available. So it was really a good. I was wrong, so it was really good news. The only thing I want to mention here too is that we didn't have the backend running on the desktop. Not that it's not feasible, but it implies a lot more stubbing work because the architecture between your desktop and the MCU is way different than when you are working with a Linux and some embedded Linux solution. So it's possible, but we didn't take the time to explore this option. So now, with everything set up, we could try our first code using the Qt for MCU framework. We reused some classical solution that you can find. It's actually some code that the Qt group gives you. You can either follow the link here, or if you have Qt Creator installed on your desktop, you just go to the tab and you will be able to set up everything. The conversion was made using Qt 6.6, and we made it to the Qt for MCU 2.5. Why do we use this example? Is because it's a simple QML-based application. There is no backend, there is no C++, so we can see every feature on the QML side of the application. The conversion was really straightforward. It requires some work. We will see it just later, but everything was really simple. The main work was on the CMake part of the application, and when we sorted that out, the main strategy was just to run the code, see where we need to modify something, and run the code again until it's working. And it took us really no time at all to have this working. Right now, I can show you, I will share my screen, this example, it will be running on my desktop. Let's go. Okay. So here we are inside Qt Creator. Here I'm selecting the desktop solution. So without any of our work, I'm just launching it. Afterwards, I'm modifying. Here I'm just pointing to the other solution. We are using the Qt for MCU kit. Now I'm launching it too. And as you can see, it's really, okay, let's make this one. Let's make this one. It's about the same. If we are looking at it, what's different? The name of the windows. Yeah, okay. Let's say I'm selecting an espresso, and here I'm selecting an espresso too. Here we can see that the sugar is not rotated. It's something that it's missing at the moment. There is not no element to do some rotation on your element, but you can easily implement something on yourself, let's say. Afterwards, we can see there is a small differences too in how the solution handled the font, but once again, it's no big deal. Here we have some differences on the sliders, but it just needs to have some customization and some new style sheet, but everything will be working as is. And when we do the brewing, we have the same animation also. So it's just to show you how easy it was to have something that is really similar. When I say it's easy, so it's straightforward, but it requires a lot of modification. On our side here, it's just some differences between the different files. Here we can see we had to rewrite some part of the UI, and what I wanted to show it's here we had to use other type of element because they are not in the Qt Ultralight framework yet. Here we have the use of anchors instead of using layout as we are used to. Okay, I think it's enough for this little share, and we will go back to the presentation. Here, okay, it's everything we saw. I won't go in every little column. You can look at it afterwards if you want, but it's just to say that most of the features presented in Qt Quick are really similar in Qt Ultralight. It was really simple, and every time we hit some problem, we had a fallback strategy that took no time to implement. Here, it's another example of an application. It's way more complex. It's an EV charging station, and the goal is to show you the differences between the C++ and the QML interfaces. The C++ API is different from what we are used to in the Qt QML, but it's actually simpler, so it's a good thing. And we will just see how to create C++ models and how to create C++ backend singleton to share data across your application, and how we dealt with this problem. So here is just an example of the C++ model. On the left, you have the one in the Qt Quick version, and on the right, the one in the Qt Ultralight. So if you are familiar with how the Qt Quick is working, you are seeing the really used macro Q property, which declares an element that you will be able to see and display on the screen, and everything on the right of the Q property enables to modify, to see the modification go live, and everything. All this part is handled with only one line in the Qt Ultralight, in the Qt Ultralight version. As for the C++ singletons, those one are to export behaviors, not only the visual data like the model, and you want to have it all across your application to be able to display everything. This part has also been simplified. So once again, you have an example on the right, and as you can see, you have also to be a bit familiar with the Qt Quick keyword, let's say. When you want to have an enum being transferred all over your application, you need to have several macro to be able to, the metadata system will need those macro to understand the data behind the enum. Here, just one keyword, enum, and everything is handled for you. So once again, for the developer side, it's really it's some time saved, let's say, and everything is possible because actually in the Qt Ultralight version, the code is converted in C++. So yeah, the interfacing is really easier that way. Some remarks that we got when we just looked at everything in the Qt Ultralight code. So it's a subset, as we said, of the Qt Quick environment, but we are really seeing it growing rapidly. So it's really great. We need to think a little bit differently as we have other solutions to implement. And we also need to sometimes implement custom solution, but yeah, it's also part of the fun. This one, it's almost as we just saw. It's an example of a control, specific ones. On the left, you have the version with Qt Quick. On the right, the version in Qt Ultralight, and it's just the same. The layout are not here, so we have to use the encores. The text are not handled the same way, so we had to modify that. And we are not using bounding value for the margins to spare some resources.
I just want to point out, sorry, Rémi, because on your screens, the people who are watching, obviously it might look small, that everyone will get the slides afterwards. So you'll be able to zoom in and see the beautiful code yourself. So it's fine.
Yeah. Okay. And one last example is a custom control that we created. We are used to do that also with the Qt Quick. Usually extending the Qt Quick item and using the same graph API, but this is not, it doesn't exist in the MCU world, but you have access directly to the frame buffer. So if you remember, I said I saw the MCU world where you light every pixel from a specific color by hand. Yeah, I was not that wrong because here it's what we did. We wanted to have a gradient for this charging bar. So we extended the painted item using the Qt Ultralight type to be able to really handle a gradient when the bar is growing. once again, yeah, you will have some time to look at that, but it's just the implementation that we did to be able to have, you don't have to trust just what I said. You can run it at home and you will see how it works. Okay, so now some thoughts, let's say. The first one is how to write Qt Ultralight application that are compatible with Qt Quick. The naive approach is to say, yeah, I can limit everything I'm doing on my Qt Quick application, and that way, everything I develop it only once, and it will be working, and you will have everything running on the MPU and the MCU. However, you will miss out on a lot of functionalities that are really great on the Qt Quick side. So it's not really the approach that we want to push. Maybe we can, yeah, thank you. Another thought is that if you already have some MPU code source, you can migrate everything to the Qt Ultralight. It's not difficult, as we saw, but it might require some time and effort because you have to rewrite all part of the code. So it's a solution, but we have to be aware that there is a cost. So the best thing we think is to start writing an application in the Qt Ultralight world, and when it's needed, when you want to add a specific functionalities for your MPU version of the application, extend it and write some specific code for your MPU. And the three bullet points left are more like if you are like us, coming from the MPU world, you know that you must be careful with the resources, but yeah, it's even true in the MCU world. So be careful when you are using images, when you want 200 plus screens for your application, it's maybe not a good idea. And so, yeah, the final word, it was really fun and great to work with this tool. It was really interesting to see that knowing the Qt Quick world, it was really easy to go into the Qt Ultralight. I think it's really the goal, and it works just. And the subset of control we used, everything was working wonders. The tool is production ready. We saw it. So yeah, we had sometimes some things that we carry from the MPU world is not working in the same way on the MCU. So obviously we had to relearn something, but it was really light. And yeah, one last thing, as usual, the documentation, the community, and everything you can find on the Qt resources, everything is of great quality. So it was really easy if we had questions. So my only hope is that we can find some partners to now do a real project with this kind of technology.
Amazing. Thank you so much, Rémi and Yoann. Gleaming review from you at the end there, Rémi. That must be nice to hear, Yoann. Rémi's like, it's brilliant. I love it as a software guy. That's perfect.
Very happy to hear, for sure.
Exactly. As I said, and I'll say it again, for anyone who is like, I want those slides, I need to look at them in more detail, they will be sent out after this. Does anyone have any questions? I can see a few now, so I will start asking them. I think this relates to more towards the beginning, Rémi, when you were talking about the sugar cubes and how they didn't like rotate and how you had to do a few things. Our friend from Munich asks, those styling issues, does the toolchain for QUL generate any warnings, build/runtime ones?
No, because it's not really a warning. If we are really talking about the cube, it depends. Okay, if there is the rotation item, it won't work because the compilation it will say that the element is not recognized. But if you modify your code afterwards, it's just not rotated because there is no rotation. So yeah.
Yoann, do you have anything to add to that on Qt side?
Yeah, so when it comes to styling, maybe one element here to mention to understand a bit also why is it different is that Qt Quick Controls essentially comes with styles, right? You if you use the Qt Quick Controls on the Qt, you know you have a selection of styles like Material, Universal, Basic, and some other ones. Basically, today in Qt Quick Ultralight, none of these styles exist. We have one unique built-in style, which does not look exactly the same. So that's why it looks different. So, but in I would say real life application, you would have, of course, your own style. So if you need one style on MCU and MPU, you would create your own custom one that would look basically the same on MCU and MPU. But the default one, yeah, there today are no commonality between them. Yep.
Okay, perfect. Well, we've had a comment saying that it's understood, you've explained it well, so that's great. We've got another question. Thank you for the workshop. That's okay. Thank you for being here. What are the requirements to MCUs and the code, e.g. which real-time operating system drivers to access screen to use Qt Ultralight? I can put it on the screen if you'd like to see it so that you can, there you go. So you can read it yourself because I know sometimes context is key.
Can take this one maybe. So the requirements are actually very simple for Qt for MCUs. It's much less than Big Qt. These are documented, by the way. Maybe I'm not sure if I can put a link somewhere here, but if I can, I will later on. But essentially, on the RTOS level, there's no requirements. You can run bare metal, so it's fully optional. There's zero dependency. As for the display, essentially, the only thing you would need as a prerequisite is a display driver. That is all. I mean, we do not provide a display driver. For all the platforms we support out of the box, we basically use the drivers that are provided by the vendors for a given MCU and development kit. If you adapt that to something else, the prerequisite would be that you have a functional display driver that you can integrate together with Qt for MCUs. But that's essentially it. I mean, basically just a few drivers depending on the features. For sure, a display one, you might need a touch driver if you need touch. And I might be forgetting something, but I don't think so. That's essentially it. It's just a few drivers that you need to integrate.
Okay, amazing. Yoann, if you send me the link, when I send out the slides, I'll include that, as well as the coffee demo that Rémi used, that you saw. So I'll send everything out as part of the package. Rémi, is there anything you want to add to that, or can we move on to the next question? No, great.
It's perfect.
Amazing. Another question. Will it be possible in future to build an application, just one of them, for both MCU and MPU without the need of migrating or porting? I think that's a device maker's dream, right? Just to build one for all.
Yeah, as you said, maybe it's a dream. At the moment, we can almost do that, but once again, the targets are really different, and even if the capability of the MCU are closer and closer, it's not in the same way. I mean, when we are working on MPUs, we are integrating web browser, we are using videos, we are using a lot of things that really needs powerful hardware, and I'm not sure that it's not soon that the MCU will be able to do this kind of features.
If I can add something here, I would say that it depends really on the use case. For simpler use cases, it is possible today on the graphic side to create basically the same application that works on both. But there's one key difference that today makes it not possible to have the full application exactly the same between MCU and MPU is the backend side. As you have seen, I think, from Rémi, the APIs today are different. And also, we do not today offer what's known as Qt Core, for example, libraries. So, for example, for containers, for strings and all these things. So they do not exist. There's no equivalence. So of course that means that you need to write this differently on MCU. So if you consider also the backend, then no, it is not exactly the same. However, again, this might change and evolve in the future. The vision generally, of course, is to offer as much as possible from Qt also on MCUs, including all kinds of other libraries from Qt, not just Qt Quick. So in the future, this might be let's say easier and easier to have one common code base for MCU and MPU, but today it remains mainly focused on the QML part and the GUI part.
Yeah, I think that kind of answers this question as well, which I'm going to put up, which, let me add it, which basically is saying, you know, what if I use the same code on MPU as I did on MCU, but as you said, it will need.
Right, yeah, in this order, let's say if you start, and as Rémi has said as well, I think at the end, if you set up a workflow when you need to target both, where you actually create first as a subset, you should start with the subset, and that will work just as is on MPU. There's no need to port anything. It's for anything that's different that might need to be ported. But the common subset, if you can run it on MCU, you can also run it on MPU.
Okay, that's good to know. We have another one here. So how is performance of a QE application running on real-time operating systems?
I could take this one. I don't know if, Rémi, you've observed specific things in your case, but on my side, what I can say here, of course, this can vary widely depending on MCU itself, on the resolution, on the application. But generally, let's say that some of the top tier MCUs today with graphics capabilities, and by that I mean acceleration for certain things, it is possible to drive actually up to full HD at 60 FPS. It is actually possible on very specific MCUs. On some less capable one, you can do 60 FPS during animations, but then resolution would have to be limited to something smaller. Typically, again, 800 by 480 or even lower. So it really depends. It's a challenge, definitely. Often with graphics, you need to be very aware about what you're doing for performance. But let's just say 60 FPS is possible, depending on the use case, and sometimes you need to implement a bit of tricks to make sure that in the end it does look good and that it performs well. Yeah, a lot to talk about potentially here, but it's just the general message. It is possible to actually very smooth applications as well on these.
Yeah, of course. And I suppose the plug is obviously if you're using the Qt tools to help you, and then a services company like Witekio to do the rest, then it's golden. We can do it, but that's the plug, and I'm not going to do it. I've got a question here that came over email talking about how much flash memory does Qt for MCUs require?
Right. So again, will vary on multiple parameters and depending on the context, but we've observed based on multiple benchmarks, application demos, real life application, that a minimum for, let's say, a somewhat simple application would be 500 kilobytes of flash memory, so for the code. But of course, it can go anywhere higher depending on what you're doing. But again, the average would be between 500 kilobytes and maybe 10 megabytes. That's fairly average depending on the assets.
It's a good range. Okay, another question here. Could Qt Ultralight application also run bare metals on the MCU in theory, or is an OS or a real-time operating system mandatory?
Right. Yeah, I think that was also covered a bit earlier. So yeah, no, it can run bare metal. An OS on an RTOS is completely optional on MCUs.
Okay. If that is it, I cannot see any other questions. If anybody else has anything to ask, please get it in. Otherwise that's it. Our experts are done. Thank you so very much for joining us. Thank you to Yoann and to Rémi for spending your time to give all your knowledge and information to us. It's been really helpful. As I said, the slides and the links for the different tools and documentation that you need will come to you very shortly. And I hope you've enjoyed it. And thanks again to our speakers, and have a lovely day. Thanks, guys. Thanks, Rémi. Thanks, Yoann.
Thanks.
Bye, guys.
Bye-bye.
Bye.
Bye.